All right, what's up? Oh, that is sorry, that's a little far away. My fault. What's going on, everybody? My name is Jake Selesny. I am doing this as a final project for my algorithms and complexity class, also known as CSE 381. Ooh, you're looking at a lot of me. My fault. And so this is going to be my presentation on the quicksort algorithm. So let's go ahead and start. We'll start it in full screen. So here's the neat little title. I thought it was cool. Little minimalistic kind of thing. Um, so let's talk about the purpose of a quicksort algorithm. So a quicksort algorithm is like any other sorting algorithm. You are going to use it pretty much to sort any unordered list or anything like that. Just any unsorted datum, I guess, is the way I worded it here in the presentation. It is a very it's kind of in the name. It's a quick sort. It does this in a very efficient manner. And I will get into the guts of that kind of once we get into the code and once we get into some of the later portions of this video. It uses a divide and conquer strategy, which I think is really cool. It's very similar. The merge sort kind of does something very similar. Uh, this quick sort is faster though than the merge sort. It is more efficient algorithmically. So, and it does this using recursion. So we're going to kind of get into that. Let's go to the next part, methodology. So this is kind of a very basic step by step of how you would write a quick sort. Um, so the first thing that is necessary is you're going to pick a pivot point, right? Obviously, you can't have an empty list or anything like that, so do check for that, please. But you need a pivot point. A lot of people do the last point in the array. That totally works. And that is, if you're working with an unsorted array, that is great because it's not going to be the greatest value, or the odds of it being the greatest value are not as high. Let me get some water really quick, y'all. But yeah, it that is something that is typically done there. Um, uh, After that, you're going to divide it in sublists into sublists based on those comparisons. So, you're going to have a left, a right, and equal, basically. The left list is going to be anything that is less than the pivot point. The right list is going to be anything that is greater than, and then you're going to step into the recursion there. So you're going to do that for each sublist until you have a sorted list of two or one, whatever it winds up being. And then once that is done, you're gonna need to go back up the recursion and combine all the lists back together, and that will come out as a sorted list. Knock something over there. So these are the performance. I didn't pick these pictures; they were part of the kind of template that I was given. So they're cool though. So your best case scenario is going to be O of n log n, and your worst case scenario is going to be O of n squared. Um, so your best case scenario is it's O of n log n. Well, let's actually, you know what? Let's get to the code and I can explain that there. So we'll walk you through step by step in the code, and then I will explain there why it is O of n log n. Um, So, this is my quicksort function, and you can tell up here I did import random, and that is because I have two kind of ways of doing the quicksort. So instead of picking the last element, in this time around I'm picking a random element. So I set this up. Oh, I already ran through this. So I kind of set this up to where it would print the values step by step, and we can see. I think what I want to do though, actually, let me do it this way. So I will take this. I will put it right here. Let's make this, a little bit more organized for y'all, so it's not terrible to watch. Um, and we'll take this one and put it right here. So you'll see the pivot, the left, the right, and yeah, the pivot, the left, and the right lists. So these are our numbers right here. So it's just 1 through 8 in a random order. So it's not that complex, right? Um, and we will run it through for the first time. So let's see. So our first pivot it picked was one. Ooh, that's a tough pick. Okay, so obviously there is nothing in that list less than one. So that left list is empty. Right is pretty much the same exact list. One is just pulled out of it. So you can see right here you have 8, 3, 1, 4, 2, 7, 6, 5. We pulled one out. One is the pivot. So this time we, oh my gosh, this is not, this one picked all the wrong kind of pivots. And so, don't worry, the efficiency is still the same, but, or at least in this case, it should be. Um, it's just kind of interesting that it did that. So, it picked 8, so now everything is going to be moved over into the left list. Let's see what it does this time. Okay, so pick 2, so now we're kind of splitting the lists into two different. Oh, it picked 2. Okay, so put everything in the right, and then we pick 6, and that's when we start splitting into really splitting into two different lists. So as you can see right here, we pick 6 on this one. So the left is going to be 3, 5, 4, and the right is going to be 7. We then pick 4. Left is going to be 3, right is going to be 5. So these are ordered. It flips everything right, like throughout this, it orders them, or the splitting orders them. Um, and there we go. At the end, we get 1, 2, 3, 4, 5, 6, 7, 8. So let's try a different way. So instead of doing these at random, we're going to do the last. So or we're gonna do this right here. Um, so let's try it. Let's see what it does differently. And so this kind of picked a random value too, didn't it? Oh no, it picked the last value. I'm kidding. It picks the last value in each one. Um, I was like, man, that's kind of weird. Thinking that it was already sorted and that it didn't pick 8. I was like, man, what the heck? No, it's already it's not sorted, so it's picking 5. So we pick 5, 3, 1, 4, and 2. Obviously, are going to the left list. Right, 8, 7, and 6. And then this next one, we pick 2, which is the last one. So the only thing left to 2 is going to be 1. And then right is 3 and 4. So that's already, you can kind of see it's like forming. You can see it forming right there. Okay. So left is, our leftmost. We have our pivot, and then we have right. And it combines, it hasn't done it yet, but it will combine those back in to make that sublist. We're picking 4. Left is 3. Right. That's kind of the extra step that you get there. This time we're picking 6. So 6, we have 8 and 7. Nothing here less than 6. So we're going to pick 7. To the right is 8. So it now knows the order. We combine everything back in, and there we go. That is sorted. So let's talk about efficiency now. I'll kind of highlight the parts that are the um, why this is log linear. So you can kind of see it right here. So this is where it's defined as log linear. So because we're splitting it, right? We're splitting it not necessarily in half, but we are splitting this list. That's where the log n part comes, right? This is kind of when I think of efficiency, I think of, am I splitting this in half, or am I splitting this some, like partitioning this some way? If I am, there is a really good chance that I have a log of n efficiency. But we gotta be careful, right? This little, oh my gosh, I forgot what it is in Python. It's the there's a fancy little word for it too, but the for loop inside of the brackets, it's something that you can only really do in Python, and I'm sure probably other languages, but this is where I learned it. This is where we get the end part because we're still going through x for x and data, so we're going all the way to the end of the list still, just in sublists. So if you think about that, every number still has to be touched, right? Every number still has to be compared, but instead of comparing them to every other number, excuse me, it's comparing them to the pivot. So that's you're still going through every single value in the array, but instead of doing it in an exponential fashion, or excuse me, a squared fashion, you're doing it in a log linear fashion right here. So that's what makes this so quick, is that we are comparing not to every other value to one singular value and then recursing further in. And that's really what sets apart the quicksort right there. So that is kind of the big thing. Um, yes, I did this in Python, but this is a pretty universal algorithm. You can do it in any other language. I've also done it in C sharp for this class. So if you guys want to see me do it, see it in C sharp, please let me know. And I would be happy to do that for y'all. I would be happy to show y'all what I did, the differences in the syntax and such. But yeah, that is it for me, guys. If you need any further help, leave a comment. I'm happy to respond. I will help you the best I can. So yeah, have a good one. Now I'm gonna cut this off. That was probably pretty long winded, huh? Alrighty, bye bye.